That's the wrong thing I opened. What? Oh yeah, great.
Look at this number.
I'll do this one later, not today. Do we have maths later today? No, of course we don't.
I have.
You have.
Yes.
We don't. I don't. Not with you.
Half an hour later.
Um, look, the next lesson doesn't have any formulas in it.
Wait.
No, not yet. Right, where's my full screen? Is this it? This is it. Oh, what's gone? Oh. We'll have to do. We'll have to do. Alright. What's wrong with you? Center of gravity.
What lecture is this?
I don't know. I don't have the number. It's the next one.
No, it's the last one.
I don't know. Okay. I can't. I don't know. What's wrong? Hang on. Let me try again. Close. Happy now? There. Happy? Center of gravity. You got that? So, the center of gravity, what is that? It's the single point through which the full weight of the body appears to act. So I'll explain that more in detail, but that's the definition which you need.
You think you can get all this on Moodle already?
I've been very bad at uploading the videos last week or two. I've just been so busy. So you might be able to get this on Moodle. You got that? Yeah? Yeah? So what I mean by that as a picture, what's wrong, Grace? Right, so what I mean by that is, if you have a mass and you think about its weight, there is like some one point where the weight force acts. And this point is called the center of gravity. That's the idea. So the center of gravity basically is where the weight force acts. That was the picture I was drawing. How the mass is spread out will affect the center of gravity. Another way to think of center of gravity is that it's like the average mass point. So I will give some picture examples. But like here, if we think about this pulling down, we picture the force is somewhere here, not here or here. That the earth is pulling down from the middle, almost. Yeah? No? You look confused. Did I confuse you? You're hungry? No? Okay. Your confused look and your hungry look the same. Alright, continue. Yes. So, here's some examples. The father with the child on his shoulders, his center of gravity is higher because he has more mass up the top. Yeah? You don't need to draw this, but you at least need to look at this, Amanda. Why is his center of gravity to the left now? Because his bag is pulling his centre of gravity to the left. And why is her centre of gravity pushed forward a bit? Well, because she's leaning backwards and she has books forwards. So her centre of gravity is pushed forward a bit. Who is most likely to fall? Which person here is the most likely person to fall over?
The last one.
Man, postman, or
The children.
Man.
the father? Now, why is that, do you think?
There's a high
Because the movement.
Well, yes, having a child on your head is one factor, yes. But maybe a more physics reason.
higher center.
The centre of gravity is highest. Yeah. So when the centre of gravity is higher, it becomes more easier to fall. Yeah. Right. So why? Because the centre of gravity is higher. So a bit more vocabulary. Fulcrum is another word for a turning point or a pivot. It is the point at which an object turns. So if you look here, look at my hand. So if this I stick here and it starts to turn like this, look, great. You see this turning here? This point here is called the fulcrum, or it's also called the turning point or pivot. So it's the point where it turns. So for the door, it'll be the door hinge. Yeah. Okay. Yes? You got this? Good.
Then usually second or
Both fulcrum or turning point.
fulcrum.
Fulcrum, yeah.
Fulcrum.
Yes. Got that? Amanda? Yeah? Yeah. Okay. So, for example, the hinge on a door, which I actually said, the centre of a seesaw is what the children play on. The wheels on the road of a car, from a car. Your foot on the ground when you walk. When you walk, this is also a turning point. Okay, so we'll do some more examples now. So this one here, notice how the centre of gravity is above the turning point. So there's the turning point, centre of gravity is way up there. So is she likely to fall or not fall? Fall. And the base, her hands, is quite small. So this makes it even more easy to fall. So it could easily fall. Right. Now, what about this one? What do you think? Easy to fall or not? Easy, but not as easy previously. So sorry, there's some vocabulary, well not vocabulary, this is very unstable. But this one is just, I would say, unstable, because it could still fall, but not as easily. Because, what's the difference? The base is bigger. Yeah. Right. This one here, it's hard to see the picture, is neutral. This is the toy I was telling you about. You have it, great. I knew somebody would have it. So this toy, it's a bird, and the bird is made so that the centre of gravity is at the beak. So when you put the bird's beak on your finger, it's balanced perfectly. Beak. Bird's beak. You know, like the nose. You know what beak is, don't you? That's a bird. That's the bird's head, wing and wing. Yeah? Anyway, this one's called neutral. This is when the centre of gravity is at the turning point. Do you know this toy?
No.
You can look at it. It's called like, I don't know, bird centre of gravity toy or something. I'll try and find one. If I see one in the shop, I'll buy it and show you, okay? You have this at home. Back later, okay. Have you got a picture of it?
No.
Have you got it like brothers or sisters?
Yeah.
You could get one of them to use it and take a picture, and then we can show them, okay? Right. Next picture now. Now this one here is stable. because his center of gravity is below the turning point. So he's hanging. It makes him stable. If you knock him, he won't fall. He'll just go back to where he was. It's stable. Yeah? He won't fall. If you hit him, it'll just go back to where he was. So notice how the center of gravity is below the turning point. And the base is still quite small though. Yeah. So it should not easily fall. But if you punch him in the face, it will fall. Alright? Now the last one here is very stable. The center of gravity is below the turning point and the base is very big. So this door for the cat will never fall, because every time the cat goes through, it will swing and go back. Because the base is big and the center of gravity is below, it'll be very difficult for this to fall off. So it will not break easily. Yeah? So this is very stable. Okay. A little bit of a definition. The moment of a force is the force F times the perpendicular distance from the fulcrum to the line of action. So basically as a formula, it's like this. Now I'm sorry, that's a lot to write down. I guess I lied to you when I said there's not much. So if you write this down, I'll explain it. It's called the turning force, or the moment. So let me just check. I just want to check what I have. Yeah, there's just two small questions to do, and then we'll finish. Now you see there's a little picture of a man here. See him there? This is the idea of a turning force. He's trying to make this turn. He's trying to make this lever turn. Got this? How do you say the letters? This one? Does anyone know the name of this letter? Not T. Or this letter? It's a Greek letter. Tau, gamma. Tau, T-A-U, gamma. You know your Greek letters from school, don't you? What's the first one?
Alpha.
T-A-U. Alpha, beta, gamma. So this is gamma. What's after gamma?
Theta.
Which one's theta? Not after gamma. Alpha, beta, gamma, delta. What's after delta?
Beta.
No, we did beta. No, that's the last letter. Epsilon.
How to write?
Epsilon? That's this one.
Ah.
Yeah.
Some teacher write E like alpha.
Oh, ugly. Their E is like epsilon.
Yeah.
Yeah. I had one teacher who wrote their N's like this. Now this is actually a Greek letter. It's called eta. Yep. Anyway, do you have this? Yep. So just you know what? I'll do an example here. We'll make my own example. So for example, here is our car which has crashed. Usually what happens in a physics question. And the man is trying to free the car, so he has this long pole and he is pushing down, and his force he's pushing down is 1,000 newtons.
What's this?
What's what?
A crash car.
This is a car.
Ah.
Crashed. Now, what's the name of this point here? This is called the fulcrum. So I'll just write F here for fulcrum. So as he pushes down, okay, he wants the car to move up, of course. So this is what I mean by a turn-in force. He is turning this way, and he wants to make the car turn this way. This force you don't measure in newtons. You measure this force in Newton meters, because the formula for this turn-in force is L, and that's equal to the force multiplied by the distance. But please be careful. It's the distance from the fulcrum to the action. So let's say that this distance is 11 meters. So this would be 1,000 multiply 11, so that'd be 11,000 Newton meters. So this is my example I made up. Yeah? So, if he wanted more turning force, he has two things he could do. He could either make this bigger, make the D bigger, or make his force bigger. Which is easier for the poor, tired man?
Like you can make the length of the other side shorter, right?
Yeah, but we'll do that in a later lesson. Just for this part, what should he do if he wants more turning force? Yeah, just make this bigger. So if I go back to my picture, you see here, it's kind of like a joke picture. Where's it gone? Oh, sorry. That if you had a lever long enough, you could move the whole planet. It's like a joke in physics. I know it's not funny. But, yeah, actually this here is called a lever. This thing here is called a lever. Not a stick or pole, a lever. Yeah? Let me see, that's, yeah, same thing. Yeah, it's the same question, basically. Okay. Can you
No.
take this picture? When's our next physics class?
Never.
It's next week.
Next week Friday we have physics class.
No, I think it's sooner than that. Do we have physics tomorrow?
I don't
No.
know.
So you have the weekend to do this.
Ooh, too short.
You have Friday
I need
evening,
1 week.
Saturday and Sunday.
I need 1 week.
Don't you feel your English getting better?
No.
It is.
No.
Think of all the words you learned in physics.
Oh my
hash
God.
brown, oatmeal, uh,
Orange?
porridge.
And physics.
Yeah, yeah. You see, you don't learn that in English. No, no. You need to go to physics for that.